And now we get to continue our discussion about IP networking by talking about subnetting for hosts. Now, subnetting itself is the idea of taking a large network, such as a large Class A network. So, for instance, 10.0.0.0/8, which hosts nearly 16.7 million addresses. I don't need a network that can handle 16.7 million addresses. In fact, I don't know very many people that do. 16.7 is not just big, that is really big network in your environment. So there may be reasons why I want a smaller network. For instance, let's say I have a small office with 100 people. Well, in that case, I don't need 16.7 million addresses. I need 100 addresses in my environment. And so I want to take this large network that I have and I want to break it down into a smaller network capable of supporting 100 people. So this is a process called subnetting, or making sub-networks, specifically and sizing them specifically based on the number of hosts needed in that environment. So in order to do this, we have to take pretty much 3 steps, 2 or 3 steps, depending on how you count them. The very first thing we need to do is to determine how many addresses we need. Let's say, for instance, I need 29 hosts. Let's say I'm setting up a very small office or a classroom, and I need specifically 29 computers to be supported in that network environment. So once I figured out how many computers I need in that environment, I have to add 2 additional addresses because I have both a network and a broadcast address that need to be included onto that. Remember, the very first address in a network is the network address. The very last address in the network is the broadcast address. So because those aren't usable, if I need 29 computers, I have to add 2 to that. 1 for network, 1 for broadcast, which means I now need 31 IPs. 31 IP addresses. All right, so I now know that I need 31 IP addresses in my environment, and so now I need to essentially use powers of 2 to determine how many bits of host addressing I need. So basically what I do is I come up here and I start writing out numbers, so, in powers of 2. 2, 4, 8, 16, 32, 64, 128, 256, and so on and so on. I then figure out, I then number these. Well, 1, 2, 3, 4, 5, 6, 7, and 8. And then I look at the number of IPs I need, 31. And I look down the list here. And what I'm looking for is I'm looking for the number that is larger than my number of IPs, than my necessary IP addresses, but not excessively larger. All right. Hopefully that makes sense. So I look through this list. 2, not good enough. 4, no. 8, no. 16, no. 32, yes. I could go with 64, but 64 is way larger than I need. That is not the smallest number that is large enough for my environment. That is 64 is larger than what I need for my environment. So I don't need 64, I need 32, which then tells me I need 5 bits of IP addressing for my hosts. Okay, so 5 bits. That's the magic number here. I wrote out my numbers, my 2, 4, 8, 16, and so on. I numbered them with the number of binary bits it takes to make those. Remember, 1 bit gives me 2 numbers, a 0 and a 1. 2 bits give me 4 numbers, 0, 1, 2, 3. 3 bits gives me 0 through 8, or sorry, 0 through 7, and so on. So 5 bits gives me 32 possible numbers. I need 29 hosts, 2 more for network and broadcast, and so 31 a total. So 5 bits is what I need. Okay, so now that I know I need 31 host bits, I subtract that from 32. Remember, IPv4 addresses have 32 bits in them. There's 4 octets. 4 times 8 is 32. So 4 8-bit numbers gives me 32 bits total. So I subtract 32 from it. So 32 minus 5 gives me 27, and this is my new CIDR number. So if I started off again with the 10.0.0.0, originally it was /8. Because I need 29 IPs, it's now a /27. So I've taken one huge network and I've broken it down into thousands and thousands of little networks. Thousands and thousands of little networks that can handle up to 30 usable IPs in each of them. Again, the 30 usable IPs, I look here, it says 32. Remember, 1 for network, 1 for broadcast. So 30 usable total IPs per /27 network. All right, so let's do some more examples. The 172.20.0.0 network, if I look at it, the range classically is going to be a Class B network, which means traditionally it's going to be a /16. So I have some requests here. I need a network with 12 hosts. So again, I go back to my numbers: 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, and 4096. And I'm running out of room there. I then number these with the number of bits it takes to fill them out or to create them in binary. And then I look, 12 hosts. I look down my list here. 8, not enough. I'm sorry, 12 hosts plus 2, which means I need 14. There we go, 14 hosts total, 14 addresses total. 8 is not large enough. 16 is larger than I need, but it's still the smallest possible solution. So 16 is what I get, which means I need 4 bits. So my new network for 12 hosts is 172.20.0.0 / 32 minus 4, 28. All right, 31 hosts. Now this is where we have to be careful, because if I look down my list, I'm immediately going to look down here and I'm going to see 16, no, 32, yes. But I have to remember part of step number 1 was I need to add 2 to it. So 31 hosts or 31 usable IPs is not the same as 31 addresses total. I need to add 2 to that, which means I need 33 addresses. So 32 is a no-go. I then need to go up 1 more level to 64. So my new address, 172.20.0.0 / 32 minus 6 is 26. 500 hosts. Well, this is where I'm glad I had enough screen resolution in order to keep writing beyond just the first few bits. 500 hosts plus 2 for network and broadcast. I now have 502 hosts. I keep scrolling down here and I find 256 no, 512 yes. So that means I need 9 bits. So my network address, 172.20.0.0 32 minus 9 is going to be 23. 3,300 hosts. Ooh, that's pretty big. Again, I go down my list here and I see, well, 1024, not enough. 2048, still not enough. 4096 is the next one. Now, if you look at that, you're going to start seeing, well, I'm wasting nearly 1,000 host addresses there. Going between 2048 and 4096, there were no other options in my powers of 2, in my binary world, but I'm still wasting 700, nearly 800 host addresses by going with 4096 or 12 bits, as opposed to what I stated that I needed. And that's just the way binary works. There will be some wasting. It's still the smallest possible option while still meeting all the needs, but it is still wasting a lot of IP addresses. And that's fine. For the most part, with the exception of out on the public internet, there is not a scarcity of IP addresses, so it's not that big of a deal. So 3,300 hosts is 12 bits. 32 minus 12 is 20, which gives me a CIDR notation of 20. And then lastly, 2 hosts. Look over here on my list, and if you followed right along with me, then you're like, oh, that's wrong. 2 hosts does not mean 2 addresses. 2 hosts means 2 usable, but I need 2 plus 2 for total. So 2 hosts is not 2 addresses. 2 hosts is 4 addresses, which is the next line right here, which is a 4. Which means my address my network range, network size is 172.20.0.0 / 32 bits minus 2 is 30. And that's basically what it comes down to, is you just look at the number of addresses you need in a network. You make sure you've included your network and your broadcast address. You look at your powers of 2 to be able to figure out how many bits are necessary in order to meet those sizes, and then you subtract it from 32, since there's 32 bits total in a network. And by doing that, we've created several smaller networks. One more example, let's say I just wanted 250 addresses, 250 hosts. Well, I look through my list here, and that actually comes out to 8 bits. 32 minus 8 is 24. The reason why I'm drawing this right here is because 24 is every 8 bits is a different octet, which means this octet right here I can easily change. And the reason why I'm saying that is because if I wanted 250 hosts for one network, well, I'm going to go with 0. If I wanted 250 hosts for my second network, so my second small office, my second branch, the second floor of my building, the second network would then be 172.20.1.0/24. So I've created not just a smaller network, but I've created multiples of them. So now I can have a 0, I can have a 1, I can have a 2, a 3, and so on. And I can use this middle block, because those are the 8 bits that are different from the original 16 and the new 24, in order to define additional networks in my environment.